So in this section, we talk about some rules for elementary derivatives. So let's begin with constant rule. The constant rule, constant rule. So if you have a function f of x, which is equals to some constant c, then the derivative of this constant function equals to 0. For example, let's look at some examples. A, if f of x equals to 3, then the derivative of this function equals to 0 because 3 is a constant. This 3 is a constant, so the derivative of 3 is 0. Now the second example, y equals to x negative 1 over 3, let's say. So the derivative of y, again negative 1 over 3, is a constant. So the derivative of negative 1 over 3 is 0. Or if we have another example, y equals to pi over 3. So you know pi is a constant, 3 is a constant, so constant divided by a constant, which is constant. So y prime equals to 0. Okay, now the second rule is power rule. Power rule. Power rule. So if we have a function, power function, f of x equals to x raised to the power n, then the derivative of f of x equals to n times x to the power n minus 1. So let's look at some examples. A, suppose f of x equals to x to the power 7. So the derivative of this function f prime of x equals to, so you bring 7 down here, times x to the 7 minus 1, so which is equals to 7 times x to the 6. Then another example, let's say y equals to x raised to the power negative 6, then y prime equals to, here n is negative 6, so you bring this negative 6 down here, then x to the negative 6 negative 1 from the formula of power rule. So which is equals to negative 6 x to the negative 7. Okay, one more example. See, y equals to 1 over x square, So we can simplify this, which is equals to x raised to the power negative 2. If we take the reciprocal, you just change the sign of the exponent, sign of the exponent too, so you change the sign. Okay, now the derivative of this function y prime equals to, again, so it becomes same pattern as this one, so you bring the negative 2 down here, then x to the negative 2 and negative 1, which is equals to negative 2 x raised to the power negative 3. Again, you can bring the x exponent negative 3 down here, so it's gonna be x to the 3. So you change the sign when you bring it down. Okay, one more example. So if y equals to radical cubic root of x square, this means, you know, the nth root is something like this. Nth root of x, this equals to x to the 1 over n, 1 over n. Okay, so for this case n is 3, so you can write x to the 2 over 3, 2 over 3. Now if we take the derivative y prime, which is equals to, now the n, the exponent is 2 over 3. So we bring this down here, 2 over 3, then subtract 1 from this exponent. So this equals to 2 over 3 x raised to the power 2 over 3 minus 1, which is negative 1/3, negative 1/3. Okay, then another example, if y equals to 1 over radical x, again radical x means the power of x is 1/2, 1/2. So we can simplify this if we take, if we put it in the top. So you change the exponent, the sign of the exponent, so it's going to be x to the negative 1/2. Now the derivative of this function is, you simply apply the power rule, n equals to negative 1/2. So you bring it down here, negative 1/2 times x to the negative 1/2 minus 1, which is equals to negative 1/2 times x to the negative 1/2 negative 1, which is equals to 2, and negative 1 minus 2, so it is negative 3 over 2. So this equals to negative 3 over 2. Okay, the next rule is constant times a function. Constant times a function. Constant times a function. This means if we have y equals to some constant k times a function f of x, so then the derivative of this function y prime equals to, you keep the constant aside times the derivative of the function f prime of x. Okay, now let's look at some examples. So f of x equals to 4x cubed. So what is the derivative of this function? Here you have a constant 4 times a function x to the raised to the power 3. So this equals to, you put 4 aside times the derivative of x cubed. Now you're going to apply the power rule. So 3 times x to the 3 minus 1, which is 2, this. Now if we simplify this, which is equals to 12x square. Okay, now second example, y equals to let's say x to the 4 divided by 12. So you see, this is a constant time function, but we write a function divided by a constant. But we can rearrange this as a constant time functions. 1 over 12 times x to the 4 is the same thing. Now we can take the derivative. So leave 1 over 12, which is constant, and derivative of x to the 4. So you apply the power rule. So 4 times x cubed, 4 minus 1, which is 3. So if we simplify this, you can cancel this out. So you get 3. So it's gonna be x cubed on the top and 3 in the bottom. Okay, one more example. F of x or y equals to 1 over 3x square. So again, we can simplify this. We can write 1 over 3 times 1 over x square, and which is equals to 1/3 times x negative 2. So we change the sign of the exponent. Now take the derivative. Y prime equals to 1/3 is constant, so put it as it is, times the derivative of x negative x raised to the power negative 2. So we apply the power rule, so which is negative 2 times x to the negative 3. So which is equals to negative 2 over 3 x to the negative 3. So this is the derivative of the given function. Okay, next, sum and difference. Sum and difference. Difference. Okay, the rule is, if you have two functions and f of x plus or minus g of x. So let's say this is y equals to this, then the derivative of y is f prime of x plus minus g prime of x. Okay, example number 1. So f of x equals to 3x to the 4 minus 2x cube. So it's a difference of two functions. So the derivative of this function equals to f prime of x equals to, you take the derivative of this function minus derivative of the second function. Let's say this is f of x and this one is g of x. So you take the derivative of f of x first, then minus derivative of the second function. So here 3 is constant, so constant times function rules we apply here. Then the power rule, the derivative of x to the 4 is 4x cube minus constant times the derivative of x cube is 3x square. Now if we simplify this, 3 times 4, which is 12x cube minus 6x square. Okay, then second example B, y equals to 3 minus 7 over x square. So again we can simplify this function, 3 minus 7 times x to the negative 2. So the first function is a constant function, the second one is constant time a function. So y prime equals to, so to take the derivative of first function, which is here, this is f of x, and this is g of x. So if we take the derivative of f of x, which is constant function, which is 0, minus constant times a function, so leave the constant as it is, and the derivative of x inverse 2 is negative 2 times x to the negative 3, so which is equals to 7 times 2, which is 14, negative positive, so it's a 14 x negative x to the negative 3. Okay, now one more example. See, f of x equals to 2x plus 3 times x minus 4. So it's a product of two functions. We didn't learn any formula yet. So what you're gonna do, you simply distribute this. So this times this and plus this times this minus this times this, then you distribute this and this. Okay, so 2 times x, which is 2x square, minus 2x times 4, which is 8x, plus 3x minus 12. So if we simplify this, we get 2x square minus 5x minus 12 minus 12. Okay, now if we take the derivative of this function, we can use the sum and difference formula. So you take the derivative of the first term. So 2 is constant, leave it as it is, and derivative of x square, which is 2x, So 2x, then minus 5, the derivative of x is 1, minus derivative of 12 is 0. So which is equals to 4x minus 5. So this is the derivative of the given function. Okay, the last example. So y equals to 3 over 4x plus 4 over x cube. So we can again simplify this. Y equals to 3 over 4, leave this aside, and we can write 1 over x is x inverse 1 plus 4 times x negative 3. Now the derivative of this function, 3 over 4 is constant, so leave it as it is, and the derivative of x inverse 1 is negative 1 times x to the negative 2 plus 4 times, again power rule, negative 3 times x to the negative 3 minus 1, which is negative 4. Okay, now simplify this, which is negative 3, negative 1 times negative 3, which is negative 3 x to the negative 2 over 4 minus negative times positive, which is negative. So 12 x to the negative 4. So we can further simplify this, minus 3 over x square minus 12 over x to the 4. Okay, that's all from this rule, sum and difference. And now let's look at some applications. So we put everything together. We find how to we derive the equation of the tangent line from the function. Now in the previous section you use the limit definition. Now you can directly use the power rule. So some application uh, for this function, suppose you are given a function f of x equals to x to the 4 minus 8x cube plus 7. So you find the tangent line, find or write the equation, find the equation of tangent line when x equals to 1 or at x equals to 1. Okay, so we know the equation of the tangent line is y minus y1 equals to m times x minus x1. What is m? M is the slope, that means the first derivative. So to find the slope, we take the derivative of this given function, and we are given this x1 is 1, x equal to 1, and we need to find the y1. So to find the y1, you plug x equal to 1 into the original function. So let's find the y1 first. Y1 equals to f of x1, so which is 1, f of 1 equals to 1 minus 8 times 1 plus 7, which is equals to 0. So we find the slope at 1 comma 0 at this point. Okay, now let's find the slope. So to find the slope, we take the derivative. So the derivative of f of x, which is f prime of x, which is equals to, so x to the 4, which is 4x cube, Now you can directly apply the power rule instead of the limit definition. So 4x cube minus the derivative of 8x cube, you bring 3 down here, so 3 times 8, which is 24, 24, and the derivative of x cube, which is 3x square, so this, excuse me, this x square, and the derivative of 7, which is 0, so now to get the slope, you simply plug x equals to 1 here. So m equals to f prime of 1. So 4 times of 1 minus 24 times of 1, because 1 cube is equals to 1, 1 square equals to also 1. So which is equals to negative 20, negative 20. So we have everything now. We have y1, we have m, x1 is given, x1 is given. Now if we plug everything back in this equation, then we get the equation of the tangent line. Okay, so the equation of tangent line, the equation of tangent line is y minus y1, y1 is 0, y minus 0 equals to m times, which is m equals to negative 20, then x minus x1, which is 1. Now we simplify this. So this equals to y equals to negative 20x minus plus 20. So this is the equation. This is the equation of the tangent line. Okay, next question is, where is the tangent line? Where is the tangent horizontal? So you know the horizontal line means which is parallel to x-axis. So so to get the horizontal tangent line, so we set f prime of x equals to 0. Okay, the second question is where 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 is the tangent horizontal horizontal horizontal. Okay, so if the tangent line is horizontal, that means the first derivative we set this equals to 0. So we got the first derivative f prime of x. F prime of x is 4x cube. For this, the f prime of x. F prime of x is 4x cube minus 24x square. So we plug this thing here. So we get 4x cube minus 24x square equals to 0. Now we solve this equation for x. So we get excuse me, we get 4x square is a common factor. So x minus 6, which is equals to 0. So if we solve this, we get x equals to 0 and x equals to 6. So at x equals to 0 and x equals to 2, x equals to 6, we get the horizontal tangent. Okay, then write the equation of the horizontal tangent. The last part of this question is write the equation of the horizontal tangent line. So we have 2 points where the tangent is horizontal. So the first case is x equals to 0. So when x equals to 0, if if x equals to 0, then you find the y1. So f of 0 equals to, you plug into the original equation. So original equation is this x to the 4 minus this. So if you plug x equals to 0, you get 7. So f of 0 equals to 7. So you get 7. So which is y1? This is actually y1, and this one is x1. So the equation of the tangent line is y minus y1 equals to m times x minus x1, x minus x1. Okay, so y minus 7 equals to, what is m? You know, since we are finding the equation of the horizontal tangent where the slope is 0, so m is 0. So x minus 0, actually it's a y minus 7 equals to 0. So y equals to 7. So you see y equals to 7 is a constant. That means it's a parallel to the x-axis. This line is parallel to the x-axis. Okay, now we have another point, x equals to 6, x equals to 6. So at x equals to 6, f of 6 equals to, we plug into the original equation, 6 to the 4 minus 8 times x cube. So 6 cube minus plus 7. Now if you do the simplification, then you get this equals to negative 425. Negative 425. Okay, now the equation, so this is y1 for this case. The equation of the tangent line, y minus y1, which is negative 425, y minus y1 equals to m is 0 times x minus x1, which is 6, Now if we simplify this, y plus 425 equals to 0. So y equals to, so y equals to negative 425. So y equals to some constant which is also parallel to the x-axis. So this is another tangent line which is horizontal. That's all from this section. I'll see you in the next session. Thanks all.